Hello, we are in Unit 1. This is lesson number 3, titled Learning Targets, Parallel and Perpendicular Lines in the Coordinate Plane. Please make sure that you have the appropriate note sheet so that you can follow along and take notes. Once again, if for some reason you lost it or do not have it, please go to the School Fusion page and print out another copy because you will need it. All right, let's get started. All right, so today we're going to talk about parallel and perpendicular lines. Take a second and see if you can recall what the difference between the two is. All right, so number 1 tells us in the space below, please sketch 2 lines that are parallel. Of course, sketch, we're just going to do a rough drawing of what we think they are. So, parallel lines are lines that never cross each other. Keep that in mind. So we're just going to draw 2 lines right here, making sure that we put arrows on the end to indicate they are indeed lines that go on forever and ever in both directions. And I'm going to name them, let's name this line L and line M. All right, so right now the way we have it drawn, I'm just telling you that they're parallel. We need to, of course, put in some indication so that when another person looks at our drawing, they know for a fact they're parallel. So once again, there is specific notation that we can use. We can make these 2 little arrows. Okay, when we see those, it's telling us that lines are parallel to each other. Okay, they are parallel. And then, of course, once again, using notation, we can write it this way. What this tells us is that line L is parallel to line M. Those 2 lines that kind of look like railroad tracks, that's the symbol for parallel for math. All right, so that says line L is parallel to line M. Question number 2 says, what does it mean? Well, it means that they will never cross each other. They will never touch. So we can say the lines will never touch. All right, our next question asks us to sketch 2 lines that are perpendicular. Okay, perpendicular lines do cross each other, and there actually is something special about it. They cross each other and form a 90-degree angle. Sorry about that. My screen went blank for a second. Okay, so I have 2 lines. We can label them anything we want. I'm going to label them Q and R. Okay, now just looking at these do look like 2 lines that cross each other. We can tell they're not parallel, but in order to be perpendicular, they have to cross at a 90-degree angle. So I have to draw that right angle symbol in there, that little box, to show that indeed they are perpendicular. All right, and then once again, my notation looks like this. I say Q is perpendicular to R. Of course, that little symbol right there stands for perpendicular. Our special math notation, perpendicular. And then down here it says, what does it mean for 2 lines to be perpendicular? Well, they cross at a 90-degree angle. All right, moving on. Now we're going to look at parallel lines and perpendicular lines on a coordinate plane and see what information we can pull about their slopes. Okay, so problem number 5 says find the slope of the line graphed at the right. Well, in order to find the slope, we're going to use the same tools that we've been using, and we're going to draw a triangle on here. We're going to draw our slope step. So pick any 2 points. It does not matter which 2 points you go between. I'm going to pick this point right here and this point right here. You may have chosen another set. And I'm going to draw my slope step. So I'm going to go up and I'm going to go over. Okay, and then I need to count in each direction. So I went up 2 over 3. So that means that this line has a slope of 2 over 3. Okay, I went up 2 over 3 to the right. Keep in mind for slope, our top number always indicates our change in y, our vertical movement up or down. And our bottom number always indicates our change in x, our horizontal movement left to right. Okay, so using that information, we're going to complete the next couple of problems. Problem number 6 says find 3 other points on the line through R with the same slope as the line above. Graph the line. Does it appear that the two lines are parallel, perpendicular, or neither? Okay, so there's a couple things we have to do here. Let's break it down one at a time. The first thing we are being asked is to find 3 other points on the line that goes through this point, and it has the same slope as the line above. All right, so let's start off by plotting that point. Let's plot R, which is at -2, 4. So we start at the origin, we go to -2 and up 4, which is right here. I went over 2, up 4. I'm going to erase those dots so they're not in the way, but I just wanted to show you. Ooh, that's big. Here's R. Okay, now the directions are saying find 3 other points so that they're on the same line and they have the same slope. So what that's telling us is I'm going to use this slope 2/3 in order to find other points. So I'm going to start at R, and I'm going to go up 2 over 3. 1, 2, 3. I'm going to put a point. Now, if I keep going up 2 and over 3 to the right, you notice I'm going to run off the graph. All right, so what I'm going to do is I'm going to do the opposite. As opposed to going up 2, I'll go down 2 over 3, put a point, and I'm going to do it again. Okay, same thing. I end up running off the graph, but not as much in this direction. Okay, so here is my other line that has the same slope, and it goes through 3 other points. Okay, so that was the first thing. Plot R, find 3 other points using the same slope. All right, the question now asks us, does it appear that the 2 lines are parallel, perpendicular, or neither? Well, let's take a look at them. Do they cross each other? No. All right, do they look like they're ever going to cross each other? By looking at first glance, I would probably say no. So that is indicating to me that these 2 lines are indeed parallel. And of course, if we wanted to, we could label the lines. Let's label it line A and B. And we could use our notation and say line A is parallel to line B. Okay, just a little extra pulling in that notation. All right, now the next question says, all right, well, let's practice the other concept. Let's find 3 other points on the line that go through R. We already have R drawn. That have a slope of -3, 2. Okay, so from R, we are going to do the opposite. We are going to go down 3 because it's negative over 2 to the right. Okay, down 3 over 2. So put that negative in front of your top number, and that will just tell you whether you're going up or down. So from here, from R, I'm going to go down 3. 1, 2, 3 over 2. Here's a point. Down 3. 1, 2, 3 over 2. Here's a point. Down 3. 1, 2, 3 over 2. All right, here's this line. I'm going to label that line C. Okay, so that line once again went through R like it told us to, and I found 3 other points using the slope -3, 2. Our directions now tell us use a corner of a piece of paper to check the angle formed by the 2 lines. What does the angle appear to be? Let's think about this. A paper forms a what type of angle? 90-degree angle. So if you hold a piece of paper up to the board and you kind of situate it so it's sitting right here, it should fit in nicely. And that tells us that this indeed is a 90-degree angle. So if that's a 90-degree angle, what are those lines? You got it, they're perpendicular. Okay, so we know that parallel lines can be drawn. We know that perpendicular lines can be drawn. All right, we were given our slope to talk about to help us with these problems, but there is some conclusions we can make regarding slopes and parallel and perpendicular lines. So let's continue on. Number 9 tells us to multiply the slopes of the 2 lines together. What is the product? So our beginning slope was 2/3. It was given to us, and we used it to find a parallel line. And then the other slope that we were asked to use to create our perpendicular line was -3/2. And we're going to multiply them together. Okay, in order to do that, we have to do 2 times -3, which is -6. And then 3 times 2, which is a +6. Now, of course, when I reduce that, -6 divided by 6 is equal to 1. Okay, the slope of those lines, I'm sorry, -1. I apologize, -1, of course. All right, the product of those two slopes is -1. All right, so we'll come back to that in a second. Number 10 says, in the coordinate plane, what do you know about parallel lines? Well, we know they never cross each other, but what can we decide about their slopes? They will always have the same slope. If two lines have the same slope, they are parallel. If they do not have the same slope, even if they look parallel, if they do not have the exact same slope, they are not parallel. They have to have the same slope to be parallel. All right, question number 11 asks us, well, in the coordinate plane, what do you know to be true about perpendicular lines? Okay, well, we know when we graph it, they form a 90-degree angle, but what can we say about their slopes? Take a look at number 9 to help you out. What do their slopes multiply to? That's right, -1. So we can say the slopes multiply to -1. You also may remember from last year in Algebra 1 that we said that the slopes are opposite reciprocals. Opposite meaning flip the sign. Okay, if one was positive, the other's negative, vice versa. Reciprocals meaning the numbers flip-flop each other. The fraction flips. Okay, so our example is if one is 2/3, the other is negative because it's the opposite sign, and then the 3 and the 2 flip places. Okay, so parallel lines always have the same slope. Perpendicular lines have opposite reciprocal slopes. Or if you multiply the two numbers together, they multiply to a -1. All right, anything you have a question on, please jot it down and bring it to class to your teacher. Let's move on to the next page. All right, so let's do some practice for this. Number 12 tells us the slope of a line is 3/7. So what is going to be the slope of a line parallel to that? Well, if they have to be the equal, it has to be 3/7. Up 3/7. B, what is the slope of a line perpendicular to it? All right, well, we have to do the opposite reciprocal. So if the slope is positive, it has to become a negative. And as opposed to 3/7, we flip that to become 7/3. All right, here's what I'd like you to do. I want you to try number 13 on your own. So please go ahead and pause the video. I'm going to do it as well. And when you think you have the answers, press play and take a look and check them out. All right, take a look at my answers. Now, one thing that we didn't look at before, in both the slope examples we had, there were two numbers. Remember, when you graph a line and the slope is a whole number or -2, it isn't a fraction, we have to include that second number. So what you'll see that I did right here was I went ahead and put it over 1. Okay, just so for me visually I can help see that. So if I'm doing a perpendicular line, the opposite of a negative is a positive, and the opposite of 2/1 is 1/2. So perpendicular slope is 1/2. All right, part B is -2 because parallel lines have the same slope. All right, now number 14 is a special case, and you may remember this from Algebra 1 last year. We did a lot with these types of slopes. The slope of a line is 0. Take a second and see if you can think of what a line like that is. A 0 slope is a horizontal line. Okay, is a horizontal line. So a line that's parallel to that also has a slope of 0. Horizontal lines always have a slope of 0. Think back to your Hooy-Vux. Okay, or even just remembering that parallel lines have the same slope. Now, on a perpendicular line would be a vertical line, and if you think back to Hooy-Vux, vertical lines have undefined slopes. Undefined. All right, moving on. Take a look at number 15. The slope of the line L is -5/4. The slope of line M is -4/5. Are lines L and M parallel, perpendicular, or neither? And how do you know? Okay, so here's what we have to decide. First of all, easiest thing, take a look. Are they parallel? Are the two slopes the same? No, negative 5/4 is not the same thing as negative 4/5. Okay, they are not in the same order, so it's not parallel. Are they perpendicular? If you can tell by looking at it, we can see that, well, first of all, they're both negative, so that can't be true. All right, but we can't just look at it. We have to use our mathematical reasoning. So if you remember, we said go ahead and multiply them together. If the two slopes multiply to -1, then they are indeed perpendicular. So let's take a look. -5 times -4 is a positive 20. 4 times 5 is a positive 20, which then reduces to 1. Is 1 the same thing as -1? No. So it's not perpendicular. Okay, if that came out to -1, we'd say yes, it's not. All right, so that means that they are neither, which is the case. They can cross each other, but not at a 90-degree angle. Okay, so if you're asked to prove or to show or to find out if they are indeed parallel or perpendicular, you have to use the facts that we learned in order to come up with that answer. All right, last question. Number 16, tell whether the lines through the given points are parallel, perpendicular, or neither. Justify your answer. Okay, so we are given two lines, line 1 and line 2. And we need to find out if the two lines, like I said, parallel, perpendicular, neither. So what's the information that we need to find out first? Well, we're dealing with slope. Do we currently know the slope? No, so we have to find it. Okay? Here's a formula that you have used in the past in Algebra 1 to find the slope of a line. So we're going to have to do that first, and then we will have to take a look at the slopes. Okay, so let's look at line 1. So here we go. The slope of the line 1 is going to be 4 minus 0, okay, y2 minus y1 over 7 minus 1, x2 minus x1. So I get 4 over 6, okay, which of course reduces to 2/3. Okay, so that is the slope of line 1, 2/3. Box that in. Okay, let's take a look at line 2. So I'm going to do my y's, which is 6 minus 0. I'm going to put that over my x's, which is 3 minus 7. I get 6 over -4. Be careful down there. 3 minus 7 is -4. And that reduces to -3/2. So that's the other slope I'm looking at. So take a look. Are they parallel? No. Always start with parallel. They're not the same, so they're not parallel. Are they perpendicular? Well, I do see that the numbers have flipped, and I do see the signs are opposite, but let's go ahead and multiply them just to double check. 2 times -3 is -6. 3 times 2 is 6. They reduce to -1. Bada bing, bada boom. They are indeed perpendicular. Okay, because the slopes are opposite reciprocals and they multiply to -1, they are perpendicular. All right, please pause the video, try B on your own. When you're ready, you can press play again and check out the work. All right, go ahead and take a look. The answer is neither. When you find the slope of line 1, it ends up being 3/4 when you reduce it. When you find the slope of line 2, it ends up being 5/6 when you reduce it. Okay, it is indeed neither. They are not equal, and when you multiply them, they don't multiply to -1. Now, if you're not sure about that, do it. 3 times 5 is 15. 4 times 6 is 24. Okay, so they are not parallel and they are not perpendicular. They are neither. Okay, so from this lesson, we want you to take away slopes of parallel lines are the same always. Perpendicular lines form a 90-degree angle when you graph them, and their slopes are opposite reciprocals. If you're asked to prove, you need to find the slope, and take a look at them and decide for yourself. Are they the same? Are they opposite reciprocals? Are they neither? Please bring your notes to class and any questions that you have, and we're happy to go over them for you.